Hello, hello. Welcome, my students. So, first, midterms. You guys did really good. Class average was around an 80% for both sections on the in-class. I still haven't graded the take-home portion yet because it's Wednesday for me right now. So I'll be posting this shortly to help you guys start working on quadratics. All right, so here we go, getting towards the whole point of 1311. So here we have the standard definition of a quadratic equation in one variable. Big thing to note here is the a, b, and c. A is always on the squared term, b is always on the x term, and then c there equals 0. If it is not equals and 0, it is not in the standard form, and we can't identify a, b, and c there. Now, the other property that we're going to make a lot of use of is this zero product rule or zero product property. That's the ZPP that's on the syllabus list. So the zero product rule is if I have two or more things being multiplied and I know they equal 0, I've done some algebra magic, moved stuff around, so everything's on one side, and I've written it as a product, not a sum or difference, as a product that's equal to 0. The only way to get 0 from a product is if one or both of the terms is 0. Now, mathematically, without a real-world context or outside information, we don't ever know which one is 0, so we just set them both equal to 0 and say, could be either of these answers, could be both, depends on the problem, so I just give you both. So that's what we're going to see, but when we get to word problems later on, we might check one of the answers out. Just because a negative number very often doesn't make sense, but there are going to be some instances where we do want the negative number and the positive number is actually extraneous. All right. So our first one here is just already factored quadratics that we're going to use the zero product rule on. So our first one here, x onto 4x minus 9 equals 0. Now I know, knee-jerk reaction, multiply. I see the parentheses, I multiply. Don't do it here, because then you're going to have to go back to this form. So what we're doing, since we are solving, is this is x times 4x minus 9. So there's my a and b product. So I'm going to set each one equal to 0. The first one is x equals 0. And then the other one is 4x minus 9 equals 0. And now we're just going to solve this. And some of you guys were already doing this on your homework. But the big catch is before now we've been doing factoring. And this, it's already factored. It's also, this is an equation. I can solve an equation. I cannot solve an expression. All right, so we have x equals 0 and x equals 9/4. Both of those are the answer. When you're going to input them on Alex, it doesn't matter which order you put them in, provided you put both of them and you put a comma to separate them. So this typically looks like x equals, and you got the box. I know you guys have been doing this. I'm just, double checking. So if I put the 9/4 first, make sure the comma ends up here, not down here. But the order you put them in doesn't matter. So if one of them's a fraction and the other's not, put the not fraction first. That way the comma is already set, good to go. Do not put parentheses around this or Alex will think it is an ordered pair. So it's just a comma because it's a list of answers. Some problems we might get more than 2 answers. That's okay. Other problems we might only get 1 or no real answers. Now somewhere in here, I know you guys are going to have the lecture on complex numbers as well. So This lesson, I'm going to, if we get something that would produce an I, I'm just going to say not real. But on the next one, I will start solving with complex roots as well. All right, so our next one looks like a more normal quadratic. X minus 3 times x plus 5 is equal to 0. So again, each of those binomials are in parentheses. The product is in between them, so each thing being multiplied is set equal to 0. Either x minus 3 equals 0, and we'd add 3, and we get x equals 3 as one of the solutions, or x plus 5 equals 0, and we would minus 5 to get x equals negative 5. So positive 3, negative 5. Different from the perfect pair that was in the factored form, which was negative 3 and positive 5. So be on the lookout for that difference. The perfect pair we find when we're going to factor is not the solutions, assuming that there's no a, or the a is equal to 1, then the opposite of them would be our perfect pair. But really, I just personally find it's better just to write it out. Now, I want to draw your attention to something a little weird, but I want you to look at these backwards. So later on, we're going to have some designer polynomials where you get the roots given to you, and you have to backtrack to the factored form and then multiply it all out. So you're going to do exactly what we did here backwards. So I want you to look at, oh, I know a solution is 3, and I'll say it in those words, and you have to be able to know, oh, that means x equals 3, which means I move it back, x minus 3 equals 0, or x equals negative 5, move it back, x plus 5 equals 0, and then both of those become factors. So just say for the future. Alrighty, and then our last one here, about as ugly as it gets, but still factors. So set each one equal to 0. 2x minus 1 equals 0. And if you're comfy just looking that, add 1 divided by 2, 1/2, that's fine. You don't have to show every single step here, but if you're not comfortable with that yet, I will still work it out. Just saying it for those that are, you do not have to write me every step. But if you make a mistake, I can't give you partial credit if you didn't show me where your mistake was. All right, so 1/2 is one of our answers. And then the other one, 4x plus 5 equals 0, minus the 5. 4x equals negative 5 now, and divide by the 4. Negative 5/4. So both of those would be the answer there. And again, if you look at this backwards, it's even uglier. We have to like multiply out the fraction and then backtrack. And on those, there's a couple of ways to kind of attack those problems. But again, that's coming up in a couple weeks in college algebra. I'd just like to preface, especially when it's a weird way to look at it, because you don't often think backwards, but you can go backwards here. It can be useful. All right. So here we have fancy directions for solving a quadratic equation by factoring. You factor and then you solve it. So the first step, though, write the equation in the form ax squared plus bx plus c equals 0. Get everything on one side. Sounds silly. There will be problems where you're not paying attention and you'll forget to move like the constant term over, but the terms will all be in the correct order. It's very easy to make that mistake. Sometimes you'll even use the correct number, just FYI. All right, so on these, we are just going to factor these like normal and then keep going from there. So our first one here, x squared plus 5x minus 24. Since the a is 1, I'm looking for a pair of numbers that multiply to negative 24 and add to 5. I saw quite a few of you guys kind of using the X method. So for those of y'all who haven't seen it, that's what they multiply to on top. It's what they have to add to on the bottom. And then you just got to find the pair that works for that. So 2 and 12 is going to give me 10 or negative 10. So closer together, 3 and 8. Yeah, 3 minus 8 or 8 minus 3. So 8 and negative 3 multiply to negative 24, add to 5. So those are the numbers we're going to see in the factors. So x plus 8, x minus 3, equals 0. Now we set each factor equal to 0 again. Minus the 8, the 3. And there are our two answers, negative 8 and positive 3. All right, same song, second verse, but this is the favorite and yet ugly. Everything that multiplies to negative 6, but only one of them will add to negative 1. All right, so could be 1 and 6, 6 and 1, 2 and 3, 3 and 2. So this would be positive 5, negative 5, then positive 1, so last one, negative 1. So x minus 3 times x plus 2 is our factored form. And it was already equal to 0, so just have to remember to write it. And then we split it up. If that product is equal to 0, one of the two factors must be 0. So either it is x equals 3 or it is x equals negative 2. More factoring! It just keeps going and going and going. So this will be a longer video. All right, but now they start to look a little weird here. 4x squared minus 17x equals 15. There's no 0. That 0 is necessary. So in order to force the 0, everything has to be on the same side of the equal sign, which means this 15 is in the wrong place. So our first step is to move it. Oh, I feel a Madagascar. He likes to move it. Have a 5-year-old. Too many movies. All right. So we now have 4x squared minus 17x minus 15 equals 0. Now, since we have an a number and I can't divide everything by 4, or I could, but I get fractions. I don't want fractions. So we're going to factor this. 4 times negative 15 is negative 60. And I want it to add to a negative 17. So 4 and 15 is what we started with. That would give us 11. So that's too small, so we need them further apart. So let's backtrack. 2 and 30, too far apart, so 3. 3 times 20 is 60. And then if I make the 20 negative and the 3 positive, that will add to a negative 17. So that is what we're going to do to that negative 17. All right. Now we're just going to do, we got 4 terms now, And provided we have picked the correct pair, the factor by grouping should work out nicely for us. If we did not pick the perfect pair, then you'll see a mismatch. You could still do some factor by grouping, the two things on the inside won't match. And that's how you know you picked the wrong pair. All right, so these two and these two, including that negative. So 4x squared and 3x don't have a lot in common, but first pair always have an x. So that leaves us with 4x plus 3. For this to be fully factorable, I need to see 4x plus 3 in this second set over here. So that negative 20x minus 15. The negative 20 is negative, so for sure we are factoring out a negative number. And then 20 and 15 are both divisible by 5. So I have a negative 5 here, and now I ask the question kind of backwards. Negative 5 times what would get me back to negative 20? So negative 5 times a positive 4 with an x would get me back to 20. And then negative 5 times what would get me back to negative 15? Well, it has to be positive, and 5 times 3 will get me back to 15. And see, 4x plus 3, 4x plus 3. So there is our ugly 4x plus 3. And then our leftovers are x minus 5. And now we set each one of those equal to 0. Let me make a little more room. To negative 3/4 and positive 5, which have no relation on the 3 and the 20 we had before. I mean, you can kind of see the 4 times the 5 is the 20, and there's a negative 3, but yeah. All right. So that's how crazy it can look if we have to get it equal to 0. Now here, I actually deliberately picked the problem from the test that I asked you guys to factor, but now we're going to take it a step further and we're going to solve it. So this will highlight some more interesting things that can happen. All right, so 12x squared minus 27, and it is equal to 0. It doesn't have to be at the end. It's fine if it's at the start. If you don't like seeing it at the start, you can rewrite it so it's at the end. Now, 12x squared minus 27. I only have 2 terms. And there's going to be a couple ways to solve these. But for factoring, the only 2-term factors we have are cubes, which this is not because we only have a squared, and the difference of squares, which we do have a difference. 12 and 27 are not squares. But what number do they have in common that I could divide them both by? A smaller number that divides into them nicely. And that is 3. So that means outside my factored form, I'm going to see a 3. Technically still with the 0 equals up front. And then 3 out of 12, or 3 times 4, would get me back to 12 with the 4x squared, minus 3 times 9 would be 27. And there's our square numbers that are a little nicer. Now the one on the test actually had y squared on the 27, but here we would not solve 2 variable equations like that. All right, so now 4x squared minus 9 does factor into, we got 2x and 3, 2x and 3, 1 positive, 1 negative. Technically the 3 is still there and it is still equal to 0. Now our 0 product property says any things that are being multiplied and it's equal to 0, one or more of the things has to be 0. So what we have here are 3 things being multiplied. The first thing is a number, so a little silly to consider, but I like to write it because technically that is something the zero property tells us. So our first one is 3 equals 0. No, that tells us nothing useful, which is pretty normal when it's just a constant, like extremely normal. So we look at the other two. It's totally fine if one of them gives us no useful information. What that tells us is I could divide the whole equation by 3 and I would still get the same solutions. Now the resulting equation from dividing would not graph the same, but it would have the same solutions, which on a graph ends up being the x-intercepts. When you set a graph equal to 0, it will look then like an equation like this, because that 0 is normally where we would write the y. So that's part of why we're doing all this work on solving equations, is because when you look at a graph, you often solve the equation when it's equal to 0, or you set it equal to something else and then move the something else over and it's equal to 0 again. All right, more of the same, minus the 3. 2x is -3, and divide by 2. And we get the lovely -3/2. And then same song, second verse, add the 3. And divide by the 2. So our solution is 3/2 and -3/2. On Alex. At least as far as I know for these, it will not let you use the plus or minus. Later on, when we start doing the quadratic formula or some of the square root properties, it might, but I highly doubt it. Typically, they're going to make you list the positive and negative roots separate with a comma in between them. But the 3 equals 0 here is not a solution. It doesn't give us anything for solving the equation. It does impact the graph, though. All right, now we got this ugly mess. 2x cubed minus 5x equals 3x squared. So we now have a cubic. Don't tell me we have to use cubes. Sum or difference of cubes. No. Notice, what do they all have in common? An x. So we're going to move the 3x squared over. Now I want you to look at those three terms. We do need them in descending order, descending by power, not by coefficient. So the 2x cubed is our first term now. Let me zoom this in a little more. So 2x cubed. Then the minus 3x squared is the next highest power. And then the minus 5x that was up there. And that is equal to the required 0. And they all have an x. So first thing we're going to do is factor that out. If they had a number in common, we would also factor the number out, but they don't. So we have 2x squared minus 3x minus 5 is equal to 0. Now, if we were just factoring this, if it wasn't an equation, we'd have to keep writing x in front of until we got to the final answer. And that was the mistake some of you guys made when I put a common number factor in the whole thing, is you did the factoring fine, but you forgot to include that number that was up front. I think it was a 3. Yeah, it was a 3 because it was that 12x squared minus 27. But because this is an equation, I could actually go ahead and split because this is a product. I can use my zero product property more than once. And at different stages, as long as it's a product. So x equals 0. And then when I get a solution this early on, when I know I'm going to be doing a bunch of extra work, I like to box it, or I might put like a little squiggle arrow underneath it to remind myself, this is also part of the answer, don't forget. So maybe you put a star, maybe you highlight it, whatever you need to do. You just don't want to forget it because it's so frustrating to do all this work. And then Alex is like, And you're like, no, I did it right. I'm sure I did it right. No. And then 0. So be on the lookout. Suppose that's another one to go in the big book of boo-boos. Feel free to add it if you want. All right. Now we have to factor this crazy mess. So 2 times -5 is going to be a -10. And it has to add to a -3. Well, there are not a lot of factors we can choose from here. In fact, it is indeed the pair we multiplied to get the -10. -5 and 2 add to -3, multiply to -10. All right, so 2x squared minus 5x. When I remember, I prefer to put the negative number first because it makes factoring the second pair not as stressful. And factor by grouping, these guys have an x. 2x minus 5, and oh look, that is literally what we have, plus 2x minus 5. Now when this happens, what we need in there is a placeholder because we do need a number here. So there is a 1. I can always multiply by 1. So that is our placeholder. So when we do the next step, our ugly is 2x minus 5, and the leftovers are the x, and we need the plus 1. It has to be a binomial and a binomial to give us a 3-term quadratic. And set each one equal to 0. 2x minus 5 equals 0. Add the 5, add the 5. 2x equals 5. Make more room. Hopefully that works. All right, so 5/2 is one of our answers, or 2.5. Alex should let you use decimals if you want, but if it is a repeating decimal, use the fraction. Because Alex gets really mad with 0.333. It's like, well, that's 333 thousandths. That's not 0.3 repeating. That'd be good enough for like chemistry work, your physics work, but math is a little silly that way. So our other potential answer is x equals -1. And see, I nearly forgot it because I zoomed in. And x equals 0. This started as a cubic, so we need to see 3 answers typically. Now, some problems you're going to get some double roots. You could even get a triple root. Or in cubics, sometimes you only get 1 real root and then you get a pair of imaginary roots. So we're going to be covering all these kind of things in the coming weeks as we talk about graphing and functions. I'm just kind of giving you guys a preview on how what we're learning is going to help with that. Oh, that was the one on the left. Cool. All right, 2 more before this video is over. So here, 4 terms, straight off factor by grouping. So the first 2 have a t squared in common. And we get a 3t plus 1 as a placeholder. Have to factor a negative because the 12 is negative. 12 and 4 are both divisible by 4. So -4 times 3 would get me back to -12, and it needs the t. And then -4 times +1 would get me back to -4. And there is our matching 3t plus 1. They must match. If they don't match, then you can't factor by group or you picked the wrong pair. And then our leftovers, t squared minus 4. Ooh, 2 terms, but a squared and a constant with a minus. That is indeed the ever popular difference of squares. So we're going to have a t and a t. 4 splits into 2 and 2. 1 positive, 1 negative, and we still have the 3t plus 1. Now I have 3 things being multiplied that are equal to 0. That's fine. I'm going to set all 3 equal to 0. One of those or more than one has to be 0. And without external information, I can't tell which, so I'm just going to list them all because that's what mathematicians do. Engineers show up and say, here is this crazy math problem that I don't know what to do with. Mathematician solves it and says, it's one of these 5 answers. And the engineer says, well, it's obviously not the negatives. The mathematician goes, I don't know what you were doing with it. It could have been anything. And there are actually some times where the negatives do make sense. Like if you're talking about machining a part and you're trying to figure out, well, where do I move this? Depending on where you set your 0, you may tell it to move in the negative direction. So the negatives may actually be the numbers you wanted. So we got negative 1/3 from that first one, and then we're going to get plus and minus 2, but from the opposite side. So this will give us negative 2, negative 2, and this will give us positive 2. So there are our lovely 3 answers. So we even have all the skills to tackle some cubics. And eventually we're going to learn how to get the graphing calculator to really work for us and give us answers. So y plus 5 times y plus 7 equals 3. We have a problem. The 0 product property only works when it's equal to 0. So we cannot say y plus 5 equals 3 or y plus 7 equals 3. Does not work that way. It must be 0. So in order to begin to solve this quadratic, I have to multiply those out, then move the 3 over, and then refactor that result. Tedious. Or if you have a fancy graphing calculator, you could put the first one in y1, put 3 in y2, and then tell the calculator, tell me where they meet. And you could get solutions that way. But I do not have a fancy graphing calculator at my disposal, so I'm going to do it the long way, and I'm a math geek. I like doing that. So foiling that out, I'm going to skip some steps here. So that is going to be plus 12y plus 35 is equal to 3. Now we minus the 3, and now it is instead 32. So a pair that multiply to 32 and add to 12. 32 is a whole bunch of 2's. So it's 2 times 16, which is going to give us an 18. Nope. So we go to the next one. 4. 4 goes into 32 8 times. 4 times 8, 32. 4 plus 8, 12. Everything's positive. So everything in our factors is positive. And then we just set each one equal to 0 and solve. And once you do enough of these, and what the magic number is depends, it changes per person. So some people only need a few, other people need quite a few. But eventually when you do enough of these, parts of it start to get very routine. That's what we want you guys to have, is that fluidity and familiarity with the concepts and the procedures. So I know you guys don't like doing a lot of homework, but some of you guys, it might take 7 to 10 good go-throughs on a problem before it feels really comfortable. All of these things build off of each other though. So, you know, if you didn't do your homework back in 9th grade, 10th grade can be hard. Like sometimes that's the problem. And sometimes it's you missed one day. All right, we're going to stop this one here, and then I will record the next one talking about square roots and solving equations.